Okay, and I'm probably just going to stay up here because, and you know what? College lesson. You don't pay attention. It's your thing. I did run through the tests and my first hour. Put that Chromebook away, sir. I don't know. Don't know. I don't hear. Okay. Um, the tests. The averages. I think. Did I tell you last year? Like the highest average in one class was an 87. Ah. And then another class was like an 82ish, I think, and the whole class averages together were like an 85. And first hour was an 86. Oh, they still had 6 people that left to take it. Your hour was an 80. I don't know if I should share that or not. Too late, I guess I already did. Okay, but we do have a problem. We got a lot of A's and we got a lot of prize winners, and we do have a lot of F's. And I don't know how to address that. I know, some people might say this or might say that, but we've been doing this for so long about with the over and over and over again, so many assignments to not know like what the 30, 60, 90 ratios are across from each other and all that stuff. It's a bit of a problem. I think the word problems, I don't know, geometrically, maybe not knowing how to do a drawing or not. But I will say this: if we don't get those ratios down, it's going to come back in this chapter, chapter 3. It will be referenced in chapter 4 a little bit, but you might survive 4 without it. But it comes back in 5, 6, 7, you get a little break, and then we finish the year with chapter 8, and they come back again. If you're students like I've had in the past, there are some that just never memorize them. And every one of those chapters that I just mentioned are absolute disasters. So at some point, we've got to get these figured out. All right? And they're going to be brought up here again, even when I have people taking the test. But they're going to be focused on their thing, and hopefully they won't be cheating as we do some of the kind of questions that we had there. But let's start off, and we'll get to that later. Try to draw a circle. Here's shaky Mr. Samulus. You know what? I'm actually kind of proud of that circle. Thank you. A compliment. And then I'm going to draw a bigger one just to tell you that, I'm going to use the word proportional. I don't know if someone that's really a mathematician would appreciate that word, but that's the beauty of a circle. Circumference equals pi times diameter. Circumference. So any circumference of a circle divided by its diameter equals the magical number pi. And people in ancient times were just mesmerized by that and just loved the circle. So let's draw a particular circle. And this one, you know what? Yeehaw! I want this one to be even smaller than the one over there. I want to exaggerate this, but then I'm going to zoom in on this, then we can see these as we go. Ladies back there? Oh, you're looking at the circles? Whose circle is better? Nice. All right, who won? Yeah, okay. All right, nice. All right, let's say that radius is 2 inches. Okay, and then I'm going to tell you that this is the definition of what a radian is. And I hope this really sinks in, because students really have a problem with radians, as I taught in the past. And I try to think about students of the past when I think about students of the future. All right, this is what a radian is. Well, first thing we have to discuss is perimeter of a circle. What is perimeter of a circle? Starts with a C. Circumference. When I walk if I'm an ant and I walk out on the outer edge of this circle, wouldn't you agree, by looking at my drawing of 2 inches there, that is close to 2 inches of a walk right there about? I mean, look at I'm going to hold my finger out. Oh, I'm kind of tethered here. There and there. Doesn't that look like about 2 inches also that I walked on the circle? You got a radian here, folks. This is the definition of a radian. The angular displacement from this beginning side to that ray that I create after I walk 2 inches on the outer edge of that circle is by definition 1 radian. So when the arc length is equal to the radius, then the angular displacement to get from that place to that is called 1 radian. That's it. That's what a radian is. Then I'm going to break this down even further by showing a picture that I already have created from old notes. You ready for this? Boom, 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 boom. Hey, look at the green thing right there. What if I went another 2 inches, right? then how many radians do you think it is when I go from here to here? That is 2 radians. And then what color did I pick? Purple? Oh, I don't know if I have purple. Purple. How exciting. How many radians is this if I go, that's brown. 3 radians. And then this is not a coincidence, all right? So I've defined what a radian is, and just lock it in. And then we can get a feel for radians after this. Hey, look at what I randomly put there. What is that symbol right there? Pi. You know what pi is? 3.14 radians. Okay, lock that in. A half circle is pi radians of a rotation, all right? Because if you accept that this looked like it was about, if I said that radius was 2 inches and it looked like that green arc is 2 inches, then I just told you the definition of a radian. This is what would happen proportionally. Doesn't matter the size of the circle. Look at this circle. Whoa. Okay. This is, let's say this radius is 8 miles. Look at proportionally what happens, and I could get my finger out for this. Doesn't that look like about the same size as that radius about, right? Yes, Mr. Samuelus. So when I walk 8 miles right here, then I draw this ray. What is this angular displacement called? 1 radian by definition. Now this is the time to tell you about this chapter. And I know when I give you all these extra things, some people kind of drift off into nowhere land. Okay? This chapter is actually separated into 2 parts. There's only 4 sections. So 2 sections and 2 sections. 2 sections are trig. And they're going to be almost exactly what you did in chapter 2, but radians instead of degrees. Then the other 2 parts are not trig. They're real-life applications of circular movement involving radians. Like we're going to have a question, how fast are we actually spinning on our axis right now? And then also, how fast are we traveling around the sun? Because those are both almost circular enough that we can use circle ideas in order to do that. And I can't believe I don't throw up every minute of every day. Because I throw up just on those little octopus rides at an amusement park where the legs go in a circle and then the seats themselves go in a circle. Am I right or am I wrong? I cannot do those whatsoever. So I'm surprised I don't throw up every day on this planet that we live in. I'm not sure how all that works. All right, so anyway, look at those 2 circles. 1 radian proportionally is exactly in the same spot. Does not matter how big the circle is. So anyway, just remember I said that. Then we have another thing that we have to consider in this chapter before we go into it. Dimensional, anyone? Analysis. This always blows my mind why students make this so hard. I really try to make things very easy for them because it is. All right? What we're going to do is change 7 miles per hour into, what the hey, let's do inches per second. Sorry, first hour, we took it a little bit further. To inches per second. And then I'll zoom in on this. Okay, and then just stick with me. Because actually, in the part that we don't have trig, we're going to have to do this. It's a huge part of it is dimensional analysis and converting, from that. Okay, so you have to understand, first of all, what 7 miles per hour mean. It means 7 miles per 1 hour. And you write it as a fraction. Oh, by the way, you have to understand fractions, too. Uh-oh. All right. So take a pick. What do you want to change first, miles or hours? Miles. That's what I heard first. Okay, so what you have to understand is, over here I'm going to write out an equation. What does 1 mile equal? It equals 5,280 feet. Now, in the other hour, I wrote this as a fraction. Fine, I will, but then I'm going to erase it. Do you know what then 1 mile over 5,280 feet equals? You're going to say 1 over 5,280. Wrong. What is something over itself always equal? What is something over something equal to it equal? 1. That's a lot of equals. You're right. That's what dimensional analysis is. Just multiplying by a series of things that actually equal 1. This does equal 1. We just have different labels. different, what do you call it? What's feet and miles called? Different measurements. But those two measurements are equal. So therefore, mathematically, they equal 1. So what I'm going to multiply by is it going to be that fraction? Or do I have to flip it? Because obviously the flip of this should also equal 1. And I'm not going to rewrite it. I'm just going to say that. So which one should I multiply by? That one or the flip of it? Why is it the flip? Those that know basic fractions. Miles cancel. Oh, this makes me so angry. Students are like, this is too hard. This is Lexi Samulus fraction work. Stop mentioning yourself. Oh, I just mentioned my daughter online. Oh, she can sue. Sorry, honey, I ain't got no money. I'm just a rotten school teacher, so you ain't getting nothing. All right. Anyway. Are we done? No, I changed this from first hour to this hour. We're going to change it to what now? Inches. So then what do we multiply by next? Okay, so there's 1 foot. For every 1 foot, there's 12 inches. I'm not going to finally do this. It's up to you to know what to do next. Okay, but now what do we have? We have inches, and it is going to be inches per. Oh, we got to do it per what? Second. Now you can either do this directly, or let's just break it down slowly. How many minutes are in an hour? Because I'm taking too long on this. So where does hours go? Top or bottom? Hours go on top. And then 60 seconds go. Shoot. Full of mistakes. I always make mistakes. And then hours cancel. And then what? Okay, so we have 1 minute equals 60 seconds. And then lo and behold, I always do this. I don't sit and think, okay, I divide, multiply. It's easier to not think and just get these cancellations happen. Okay, and then lo and behold, I will have inches per second. So then this is your job next, which I guess I'm going to screw up my highlighting there, but you just take all of these numbers that are left over on top, 7 times 5280 times 12, divided by 60 times 60, and you make sure you type it right, and then the answer is inches per second. Just remember I said that. Okay, now I'm going to start breaking down this unit circle. I did this later in the notes with everyone to start making, and you have a question that really pertains to this. It's number 83 in your homework. Now, I can't believe how many people every year leave that blank. It's actually starting what's called the unit circle. How many people know what the unit circle is with the degrees and radians? Only a few, only a handful. It's good. I'm glad it's brand new. So for degrees, this is 0 degrees. This is 180 degrees, right? I shouldn't have to. This is 270 degrees. This is 90 degrees, right? Now, I gave you one piece of information about radians that you're going to have memorized. And then from that, we're going to build how the coordinate plane is broken up angularly through radians. So then I could do the next thing. What did I say was over here? What radians? That's right where 180 degrees is, meaning this angular displacement is 180 degrees. It's also blank radians. It was pi. So from here on out, you know what these are? These are equal. And therefore, what is this fraction equal? That's radians. And that's degrees. What does that equal? 1. All right? In our dimensional analysis. And we can flip them. And what would that equal as well? 1. And that's our first part of our notes, understanding that. Okay, by the way, what do you think? Okay, I forgot. Get red. 360. By the way, what do you think 0 degrees is? How many radians? First, I was stumped by that. No, they weren't. They started laughing. How many radians is 0 degrees? 0. But how many radians is one full rotation? And this is something you got to get locked in. If half is pi, then a full revolution is 2 pi. And I used to break that down even further by talking about circumference of a circle. Circumference is 2 pi r, right? Remember that formula as well? Whoa, hold on. We have an illegal maneuver. Did you just grab your calculator? Hold on. I got to stop. I got to tackle a student. Everything's okay. Nothing happened. All right. All right. There we go. Oh, no. What do you think 90 degrees is? What kind of radius? Well, 180, half of 180 is 90. Pi, what do you think half of pi is? Pi over 2. These are things you're going to want to start locking in. Okay, then I got the last. Does anyone know what this one would be down here? You just good with fractions? Well, you've already done this, so you know that. But here's how I do it: 1 pi over 2, 2 pi over 2. Huh? Nothing from this group. 3 pi over 2. Is that right? Well, then this should be 4 pi over 2. Is that 4 pi over 2? Yes, it is. And this is how you move around a coordinate plane in radians. It's just fractions and it's basic. Okay, so that's good to do. Okay, what are we going to do next? You don't have to read all this. This is my old crappy notes from years ago. The first thing we're going to do is convert degrees into radians. And I got my crummy old notes of another teacher's writing here because it doesn't matter. This is Mickey Mouse. But now what we have to do is dimensional analysis. And I already wrote the fraction. You just got to know which one to use. The fraction at equals 1. What equals 180 degrees again? How many radians? Pi. This is the memorization factor. I'll have people not memorize this, and then the continuation of this will be a disaster. Okay, what do you think you should multiply by? Should it be pi over 180 or 180 over pi? Well, the word degrees is in here, 45 degrees, and that's got to go away as you see that mark there that it's canceled out. So what does that mean 180 degrees should be on the top or the bottom? Bottom. All right, and that's the point of why I'm keeping this cryptic here. This you have to multiply by pi radians over 180. I see someone squinting. Because degrees is actually a word, 45 degrees. It's a label. And I need that label on the bottom so the label can cancel. If you look at the dimensional analysis that I did with feet, minutes, hours, and all the other stuff. So you should never make the mistake, how do I convert degrees to radians? All of them are multiplied by pi over 180. Now here's the next thing. What's the sine of 45 degrees? I'm just asking a question. Some people should instinctively just throw out the answer. What's the sine of 45 degrees? Only one person? Root 2 over 2. Do you know what the sine of pi over 4 is then? Root 2 over 2. It's coterminal. Pi over 4 radians is coterminal with 45 degrees. This is half of chapter 3. Instead of taking the trig of the angle measures from chapter 2 in degrees, you're now going to trig them in radians. And we're going to do some stuff that through practice and through doing your homework, not Common Core copying, not, all that crap that I see out there, getting it actually memorized will actually in the long run make you firm in all the other chapters. Actually doing your homework, some of us. All right? Ooh. By the way, negative 270 degrees. Where would that land on this coordinate plane? Where would that land? Left, right, top, bottom? It is actually top. It's this measure right here. I just wanted to share something with you when you convert this to radians, because you're going to find out something about these radian measures. And we actually discussed this in first period a little bit. Student number 2 in this class, because I can't say your name. Lexi's already going to sue me. I don't want you. What do you know about 45 degree angle measures that end up being 45s in, any quadrant? What are they always? What's for a radian measure? What are they always? He didn't answer yet. Oh, now I hit that 180. I didn't want to go that far. You don't remember that those are always over 4s? Remember that yet? Okay. Forget that I mentioned that. Don't worry about it. Everyone just take a deep breath. All right, and then didn't we just have 3 pi over 2, right? But where was 3 pi over 2 when we were breaking this down? And I get sad. I don't get that. Well, all we did was, if you just accepted that this was pi radians, then we just broke it down fractionally. We doubled it, and then we took half of it. Look at 3 pi over 2 is the same as 270. So negative 3 pi over 2 should be the same as negative 270. And you're going to get used to this, and the quicker you do, the quicker you're going to be in good shape. But anyway, that's not the spirit of this question. But really, as you do your homework, this is what should happen. Then the last one, it's a decimal degree measure, not special. So what I did is I did use my calculator's pi button. So the previous ones are said to be in exact form. These are in exact form. Or what they would say in terms of pi, meaning leave pi alone as a variable. And that's actually said to be exact, as if the symbol pi is the exact number of what pi is, although that doesn't really exist. All right. And then this is said to be approximate form, which means you type the pi button on your calculator or 3.14 if you want a little less accurate answer. All right, so just do make sure you understand that. Okay? All right. Okay, I'm also going to do something else with this. You should get a feel for radians, and it's going to be coming up anyway. Did I have this? Did I erase those things? I guess I did, or something moved. I think I moved one of my pages, but let's just write this again one more time because it is, I think, pertains to this. 0, pi, half of pi, full rotation is double pi, and then we said this was 3 pi over 2. Do you know that pi is 3.14, right? Right? What's half of 3.14? I'll give you that, 1.57. All I'm doing is getting the decimal approximations of this. All right? And then 3 pi over 2 is 4.71. And then 2 pi is double 3.14, which is 6.28. So I just wanted you to look at that last answer we got. Where's 249 degrees at? 0.8. What quadrant is that in? What quadrant is that in? It's in quadrant 3, because this is 180, and this is 270. So I'm like right there. Doesn't it make sense now that 4.36 radians is in quadrant 3? Do you see that? So I'd like to show this to give people a feel for what radians are actually. All right? And why I should know 4.36 radians is in quadrant 3 actually. Because it's comparative to the 0, pi over 2 pi, 3 pi over 2, and 2 pi thing. So I'm also getting a point of these are coterminal. One just happens to be in degrees. One happens to be in radians. All right. Now, student number 2, look at 9 pi over 4. What's the reference angle going to be no matter what? 45. And we're going to prove it by converting this to degrees. Okay, I did blow away a student's mind on this. I just want to make sure you understand that this is over 1, I guess. And this doesn't have the word radians, but it is in radians. So what do I multiply this by? Do I multiply it by pi over 180 or 180 over pi? It's 180 over pi because of what I'm writing kind of sillily here this way. But I do want to write this way so that you understand what word gets canceled, even though it doesn't really exist in the question. It is there, though. What word disappears? Radian. In a way, it does. There's something more to radians, though. Okay? Let me press pause for a minute. All right. So, really, what you're going to do is this, though. 99% of the time, radians will have what in it? What do you think? What do you think radians will have in it? Pi. And what do you need to probably get rid of? Pi. And by the way, 9 pi over 4 over 1 is just 9 pi over 4. But I just wanted to show that. The word radians has to disappear. I don't see the word radians. It's actually there. It's a radian measure. But also, you'll know that it's 180 over pi because the pi's usually have to cancel. But not every question has pi in it. All right? And then I'll just give you the answer. This is 405 degrees. Which, is that right? Yeah. You know where 405 is? By the way, 405 is more than, anyone? 360. 9 pi over 4, this always makes me infinitely sad, not understanding this. What's 8 pi over 4? A number. What's 8 pi over 4? 2 pi. So 9 pi over 4 is more than, anyone? More than one, I was going to say revolution, but rotation's okay as well. All right. So anyway, that's what 405 is. It's also a cleaner. Anyone know formula? Is it formula 405? 409. I'm such a loser. All right. I hate being wrong. And then what you're going to see is that's a 45-degree reference angle in quadrant 1, and we could do trig on it now. All right. Ooh, an over 6. Student number 2, do you know what an over 6 is? Oh, no. So what is it then? It's a 30. The over 6s end up being 30s. And we're going to show this right now in this particular example. Hey, you want to write this down, that little stuff on the side? It'd be, a good idea. Because watch what happens. It is pi, 180 over pi you multiply by, because you want the word degree to be now on there, and also the pi's to cancel. You want the word radian to cancel. But whatever you want to look at it, I don't care. I think you get negative 150 on that. Is that right? You know where negative 150 is? What quadrant? Oh no. 3. How far short am I from finishing that angle measure? 30. You're going to find out that negative 5 pi over 6 is a 30-degree reference angle in triangle in quadrant 3. All right? And that's those connections you're going to have to make, and make them quick. Is this special? No. How do I know? Is there such a thing as 4.25 degrees? Yes or no? Yeah, it's this angle. Aw, isn't it cute? Right? Look at my hand. Beep. All right, you don't get to see that online. There's such thing. How do I know that's degree or radians then? What's not right here? What don't you see? A degree mark. I could be a real jerk on this one and put a degree mark on this. I could do that. And then guess what? That's a degree measure, and I'd have to convert that to radians. Oh, now I'm just mixing up the students, because you know what? 9 pi over 4 is just a number. Here, I'll show you. I get it, Mr. S, and maybe you don't. 9 times delicious pi, enter, divided by 4. Is there such thing as a 7.07 degree angle measure? Yes. Just a number, but it's written in terms of pi. These are things that we need to understand when we get into the world of radians. They're just numbers. They're just written in different ways. So why is this a radian? Because it's in this section, but also there is no degree mark. So therefore it is a radian. And where is 4.25? What quadrant does that land in? What quadrant? You should know, shaking your head. What is it between? It's between 3.14 and 4.71. So it's very close to that 4.36 that we had before. It's like right there. That's what a radian is. It's just angular displacement written in a different way other than degrees. Students love degrees because they can understand 180, but they don't they got to get to understand pi means the same thing as 180, and therefore all these other things happen with radians. Alrighty then. All right, times 180 over pi, and then you just get the decimal for it. Can someone do that offline? I'm going to press pause and take a deep breath here. There we go. We know 243 is in quadrant 3 as well. All right, because it's greater than 180 degrees, less than 270. So now hopefully we're getting a feel for radians and what they are. I would really, really, really make sure you have this in your notes. What it is comparative to 90, 180, 270, 360, and then get used to it. Well, as a matter of fact, it's number 83. Whoa, 83 in your book is a crucial question that you actually do. All right, and then I just did that. Okay. So I like this. No need to write it unless you like, the idea. And I think I said this before. What's the sine of 30 degrees? What is the sine of 30 degrees? Oh, nobody knows. And we just had the test. We've done a million questions on this. It's a half. What's the sine of 30 radians? A half? No way. Now that I've given you this thing, what's one rotation in radians? 2 pi, right? I'm all tangled up here. I'm going to choke myself with this wire that I'm using to... All right? So isn't 2 pi 6.28? So 30 radians is really a whole bunch of rotations. It's crazy. As a matter of fact, to find out how many rotations 30 radians is, take 30 divided by 2 pi. And it'll tell you how many revolutions it is. So is the sine of 30 degrees equal to the sine of 30 radians? Yes or no? Now we understand the importance of turning our calculator into degrees or radians, depending on the question. This is a flat out no way, because they are totally different angle measures. And that's what we need to understand at this point, why we must change our calculator whenever it is a calculator question. It's awesome. This book is amazing. I cut this right out of theirs. Good stuff, good stuff. Very readable. I'm going to be very sad to lose this book, actually, if we ever do. All right. Now it's trig time. This is the one and only one day. Are you sure? There's a front and a back of the written. Okay. This is one and only one day that you will do step one. After this, you must get this figured out, what I was talking to student number 2 about, who has done this before. You know, we'll let you convert this to a degree measure and then do chapter 2. Because really what that's all it is. One step and this turns into a chapter 2 question that you've just been quizzed on, 2-1 to 2-3. And then, it was on the no calculator part. Ow, that was not a punch.
Was it funny?
It hit my funny bone.
Was it funny?
I don't know what's going on right now. Hold on. All right. Okay. So, I'm going to do this right up in here. Maybe. What do I multiply this by to convert it to degrees? Pi over 180 or 180 over pi?
180.
It's 180 over pi. When it's in terms of, radians, and it usually 99% of the time has pi in it, you should know it's 180 over pi then, so the pi's cancel. Now, what this turns into is tan. I'm just going to write this work down here. Tan of 360 divided by 3, which is 120. All right, student number 2. Remember? What is 120? What kind of reference angle is that? 60. Okay, and I'm going to keep mentioning this, and I know this may present fear to many people, but you're going to find out any radian measure that's an over 3 when reduced will always be a 60-degree reference angle. And when you do number 83 in your book, that's the point of number 83. I hope it's 83. I hope I don't have the number wrong. It's the one where you fill out all the missing parts that I'll reference at the end of these notes. I don't care if this takes 50 minutes. This is crucial and key to the success of this chapter. And knowing that a 60, the side opposite of that is root 3. 30 is 1. And opposite 90 is 2. We're going to change that, by the way. Those that are looking at this online, I know I don't reference the unit circle yet because we're not there yet. We're going to make that radius 1. We're going to make that 2 a 1 later. Don't worry about that. Hey, who's negative, by the way, besides your teacher? 1. Okay, then what's tan? Tan is what letter over what letter? I still have people that don't know this. Toa, tix, tix, y over x, negative root 3 over negative 1. So the answer is negative root 3. So that's it. You just do one conversion and you're done. Okay, so let's speed this up. 3 pi over 2. Let's do the conversion up here. Put this in parentheses and do the 180 over pi thing here, and then do our work below. Okay. Alrighty then. I already got it. It's up to you to do the math. Where are you getting this 270? I'm calculating. Canceling the pi's. I'm taking 3 times 180 and then dividing that answer by 2. Hey, where's 270? Up, down, right, left. Where is it? Down. Hey, student number 2, if you're at 270 or 90, what's the denominator always going to be? I highlighted it. 2. All right? And these are things that you're going to see as you move along. Not there yet. Hey, what kind of dang it. What kind of trigonometry is this? Coordinate. What is that coordinate right there? No time. If you don't know that coordinate, I don't know what you're doing out there. All right? And what's R equal? What sign? What letter over what letter? Sir, y over r, negative 1 over 1. You don't know that? You're severely, anyone? Thank you. Times 180 over pi. We've been doing this for weeks. I tell you, it's every year. I got those students that for weeks don't get this stuff down so we can move on. Hey, you know what this is? I got to move that 83 over there. This is where you get annoyed with Mr. Sameless. I couldn't, anyone? Care less. This is negative 240. You know where negative 240 lands? What quadrant? And then if I move, I lost my pen. That's negative 180. How much further did I go? Another negative 60. Do you know that this is exactly the same as this triangle? But you're going to write it again until it sinks in, until everybody is 100% there. All right, what's cosine? What letter over what letter? X over R, which is negative 1 over 2. Got it? Got it. So we're going to let you do this for right now, and then you're not. You're going to have to know that. Look at that. Student number 2, it's an over what? The last one was an over what? 3, and what kind of reference angle was it? A 60 again, because negative 240 is 60 degrees, past negative 180. All right, and that's why. So you're going to find that out. So when you do number 83, which I think I do have reference down here, that's just my work again. Here's what number 83 looks like. It's called the unit circle, but really what they do is just have you pop around, have you fill in all these missing parts. And then that's when you should start making those connections, which I'll help you with later. But the quicker you make them, the better. Do you remember what a 30 degree is? It's an over what? So this is what you're supposed to do on this. Fill in the blanks in number 83. So number 83 has multiple answers. So what I'd have to do is I got to do this on every one of these. I don't know why I put that over. What do I multiply degrees by? Pi over 180 or 180 over pi, by the way? Pi over 180, so the degrees cancel. And then it's not going to be hard because the zeros and the degree cancel. How many times does 3 go into 6 or 18? So there you go. And you're going to find out that all the 30s in this position end up being over 6s. And then once you get that down, which I'm kind of telling you about that, how you find those without having to worry about the degrees is just fractions. It's all it is. The people that cannot do fractions still to this day are people that cannot deal with a fraction. And it makes me infinitely sad when I deal with seniors that can't do that. So that is why we're going to make you get these radians down, because you will not walk out of this high school without knowing how to deal with a fraction without hitting the fraction button on a calculator. And that is my belief as I stand here at this podium giving my speech that nobody is listening to right now, except for maybe, no, we won't mention.